In this question, we're simply asked, could this formula be correct? So we can see that the change in pressure is equal to F, and we see that F is a constant, times by length, times by density, times by velocity all over 2D. And that's plus this other term, which is the sum of K, again, which is constant, times by the mass flow rate squared over 2 times the density times diameter cubed. So this isn't this isn't really a dimensional analysis question. You don't need to use the Buchanan Pi theorem here. This is more of it is a dimensional homogeneity question. So for this question to be correct, we just need to check that the units of each of the terms in this equation are the same. So, as I said in the lecture, we can't add meters to kilograms. We can only add meters to meters or kilograms to kilograms. So we just need to check that these units are correct. And because they're all in different SI units, we need to take them back to fundamental units. So first thing to do is to write out each of the parameters in terms of fundamental units. So change in pressure has units of mass over length over time squared. Length has units of length. Density has units of mass over length cubed. Velocity is length over time. Diameter is length. And also mass flow rate is mass per unit time. So what I'm going to do is I'm going to compare the fundamental units of each term. So I'm going to compare the kind of dependent variable against each of the other variables. Okay, so going to compare delta P to our first term and then to our second term. So this is our original equation at the top. So you can see here that I've actually dropped the constant F and the number 2. And the reason for that is that these are constants, so they don't have units. So in terms of this analysis, we can ignore them. You obviously can't ignore them if you were trying to work out the value of this, because then they would have an effect. But in terms of comparing for units, we can ignore them. So I then substitute in the fundamental units for each term. So we've got change in pressure, length, density, velocity, and diameter. Then I just need to check the exponents of each fundamental unit, so for mass, length, and time, and check that those tie up. So on the left hand side, we have for mass, we have 1 mass unit. Okay. Then on the right hand side, there's not mass in that term. We have 1 in that term. There's no mass in this term, and there's no mass in this term. So therefore 1 is equal to 1. So we have mass on the left hand side and mass on the right hand side. So that's fine. We can take that. In terms of length, we can see that we've got exponent of -1 on the left hand side, and on the right hand side we've got 1, -3, +2, -1. And if we work all that out, it becomes 3 minus 4, so -1. So -1 is, of course, equal to -1. Tick. And we do the same thing for time. So we have -2 on this side, and we don't have time in anything but the third term, and you can see that it's -1 squared, so it's -2, so therefore -2 is equal to -2. So therefore dimensional homogeneity is conserved when comparing the first term to the second term. So now we just need to do it for the third term as well. So write in the change in pressure, and again the K is a constant and 2 is a constant, so we can ignore them, and so we just got the variables which actually have units. So substituting in the fundamental units for pressure, mass flow rate, density, and length. Then comparing units for mass, length, and time. Okay, so for mass, we can see on the left hand side we've got 1 unit of mass, and on the right hand side we've got mass squared -1, so it's 2 minus 1, so 1 is of course equal to 1. Tick. And obviously you can see this one here, so I'll come back to this. So do time first. So on this side we have -2, here we have -2, and we don't have time in any of the other two terms. So -2 is equal to -2. However, you can see here in terms of length, we have length to the power 1 on the left hand side, and on the right hand side we have no length in this term. We have -3 and -3 to the -1, which gives us +3, -3, and it's equal to 0. So -1 obviously does not equal 0. Therefore, dimensional homogeneity is not conserved for this third time, and therefore the answer to the original question, could this formula be correct? The answer is no, and that's because the units of the first term and the second term agree, but the units of the third term are different. So therefore, this can't be true. And in fact, what the true answer is in fact there is, you could say there was a typo in this question, and actually if you make it d to the 4, then this would work. So that was kind of the deliberate typo that I put in to for you to find, to show that this couldn't have been true. And in fact the right answer is it's a diameter to the power of 4.